doing number 3 from yesterday's notes. Okay, so remember number 3 is this one on your yellow sheet. So we got all the way to here, and then the bell was about to ring. So what is 40 squared?
100.
Okay, so I have 4 pi times 1600 dr dt. Okay, then what's 1600 times 4? 6400 pi, thank you. And then what's my last step if it's equal to 800 and I want to get dr dt by itself? Divide by, oops, yeah, 6400 pi. Okay, so then from there, dr dt equals, okay, and then just like some little tricks that you learned at one point but maybe forgot, if you have zeros on top and on bottom, you have the same number, you can cross them out. So 800 over 6400 is really just 8 over 64 pi, and then that can reduce to 1 over 8 pi. Easy? So good? Yeah. Is that good? The whole thing?
I think I missed this question.
Okay, can you take a picture of it?
Yeah.
Alright, so the next one that we're going to do, so you're back on your yellow sheet here. Our goal is to finish this up and move to pink today. The next one that we're going to do is going to be the 25-foot ladder. So it's kind of like 4th from the bottom. You're going to label it what number on your yellow sheet? Number 4, and then you're going to do number 4 on your notes. Okay? So number 4 about the ladder. Now, as these get a little bit more complicated, this one's not super complicated, but I'm going to start drawing pictures and labeling stuff. So for number 4, let's draw a little picture here to the side. So it says we have a ladder, and then it says it's leaning against a building. So here's the building, here's the ladder. Good so far? Okay, so we are on, it's 4th from the bottom. We're kind of like numbering them ourselves because we're not going to get to every single one. And then we're doing this question in your notes. Okay, now if you want to go home and cut these out and glue them into your spiral, you can do that. Or not. Okay, so how long is the ladder? Okay, 25 feet. Now, a ladder is not going to change, right? If it's 25, it's 25 always. Okay, so then it says the base of the ladder is pulled away from the wall, so this side is going that way. And what's going to happen if I pull the base of the ladder away from the wall? What's going to happen to the top of the ladder? It's going to be going down. So how many sides of my little triangle that I've made are changing? 2. Is the ladder length changing? No. So I'm going to label this with an X, this with a Y, just to keep like a horizontal side and a vertical side. And you'll notice we have a right triangle. Okay? So what I want you to do next is set up your find, given, when. So find, given, when, that's what we used to kind of outline these problems yesterday. Okay, so if you forgot, it's what you're finding, what you're given, when you want it, and then your equation. Okay, and then remember also yesterday we went through, we listed out all those equations. I can give it to you if you're absent. Okay, so it says the base of the ladder is pulled away at a rate of 2 feet per second. Is that dx dt or dy dt? The base of the ladder. Dx dt. So my given is that dx dt is equal to 2 feet per second. Okay, then it says, how fast is the top of the ladder moving down the wall? What would that be that I'm finding? dy dt. And remember, always a t on the bottom for these. Okay, then from there it says when, right here, the base of the ladder is 7 feet from the base of the building. Is that the x side or the y side? The x side, so my x needs to be 7. Now, keep in mind, is this always 7? No, it's only 7 at that one instant as you pull it out, and then you're going to keep pulling. So that's why it's a when, not a given, because it's not always 7. Okay? So So what equation is on your white sheet or in your brain that relates to the three sides of a right triangle? Yep. Okay, Pythagorean theorem. I don't care if you put the name in your notes. Up to you. Okay, but Pythagorean theorem says that I can do a squared plus b squared. It always equals c squared. So I'm going to do x squared plus y squared equal to 25 squared. So far, so good? Okay, take the derivative. Remember, we're taking the derivative with respect to t, so what's the derivative of x squared? 2x dx dt. What's the derivative of y squared? 2y dy dt. And then remember that 25 is a constant. So even if you don't know what 25 squared is, when I take the derivative of it, what's it going to be? 0. Good so far? Okay, let's plug stuff in. 2x, what's my x? 7. What's my, actually, let's use units one more time. We're not going to do them every time, but I'll do them right now. So this is going to be 7 feet. Okay, and then what's dx dt? Thanks. Y'all aren't going to cheer for him today?
Big Tom Day!
Come on, give that boy a round of applause. Okay, dx dt is 2 feet per second. Okay, and then when I get to y, what happens? Okay, I'm going to put a little question. I don't know what y is, but I know that dy dt, I'm not supposed to know that because that's what I'm looking for, right? So at this point, I know 2x dx dt, dy dt is what I'm looking for. This is missing. How can I go back and find that? Plug it in where? Yeah, to the original, right? If I know one of the sides of the triangle is 7, and I know the hypotenuse is 25, then I'm just one little Pythagorean theorem away from knowing how long the other side is. Yeah? So, let's set it up here. I'm going to put a little note for you. Okay, we need to go back and find y using the original before I took the derivative, which is obviously just Pythagorean's theorem. So what would I put? I'd put 7 is my x side plus y squared equals 25 squared. Okay, now I'm going to have to skip a line to solve that. Okay, so what is 7 squared here? 49. Anybody know what 25 squared is? 625. 225 is 15 squared. Okay, then what do I do next? Minus the 49 across. We all know how to do, hopefully, Pythagorean theorem. Okay, 625 minus 49. What do we get there? Oh no, 625 minus 49. Okay, 576. And what is, do you know it?
17.
No. It's 24. Did you say 24? Oh, I thought you said 4. 24 is right. Okay? Now, you also could maybe memorize all the Pythagorean triples if you want, but that sounds like a waste of time. Okay, so 24 is going right here. Okay, then I forgot to put units on 24. 24 is measured in feet. Okay, so let's work it out. My first one, I'm multiplying out. What is 2 times 7 times 2 again? So I have 28. What are my units on that piece? Feet squared per second. Okay, then plus 2 times 24 here, that's 48 feet times dy dt. What do I do next to solve? Take my 28 squared, blah, blah, blah. I'm going to move it over here. So now it's going to be 48 feet times dy dt is equal to negative 28 feet squared per second. What would be my last step to do with the 48 feet? Divide. And if I divide that by 48 feet, what's going to happen if I have feet squared and feet on the bottom? 2 of them are going to cancel. That'll leave me 1 left over where? On the top. So I'll have dy dt equals negative 28 over 48. You can reduce that to negative, what was it? 4 over 7? 7 over 12. Right? And then units would be feet per second. Okay, now, quick question. We got a negative value. Does that make sense in this question? Yes, why? Okay, yes, go back up to my little triangle. Remember, what does y represent? It represents this side. So as my ladder's being pulled away, this side is going to be shortening. And if it's shortening, then it makes sense that dy dt came out to be negative, because that side of the triangle is going to be shrinking as the ladder falls down. Make sense? Okay, so I'm going to put negative result because y side of triangle is decreasing or getting shorter or depreciating, sure. Okay, however you want to think about it. But you should understand that what dy dt is it's a rate of change. It's how fast something is changing. Okay, so it can be positive or negative. Okay, just like everything else. All right, you ready? Okay, we don't have that many left. Next one, go to the very last question here. Spherical snowball. Got 2 more left on yellow, and then we're moving to pink. It's gonna be so great. Huh? We won't have time to do all of them. Even though I'd love it. I mean, we literally won't have time. We're already like a full week behind last year. Huh?
Don't be like that. You're like,
It's not it's because they cut 5 minutes off of every class period. So if you think about that, adds up, right? It's 25 minutes a week. Multiply that by several months. I mean, I knew we'd go a little slower, you know. I mean, it's not like I've literally calculated it out or anything.
Snowball.
No, I'm saying I don't like that they shortened y'all's class periods. Like, if they'd at least done like a block schedule, I feel like it would have been fine. But
Interesting fact. James's little schnauzer named Snowball.
really, adorable. Did you name it that?
Yeah, I did.
That's cute.
You said it's a stupid name, bro. You said it's a stupid name.
I did not say that. My cat's name is Cutie Pie Perkins, so honestly.
Cutie Pie Perkins.
And my other cat's name is Milky Way. And they're both sick with a cold. They're like sneezing and have runny noses. Is that even a thing? It's nasty. I've been locking them in the bathroom and turning the shower on hot so that not on them, right? But so that they'll like get all their snot out. It said on Google that was fine, so. Google said either take them to the vet or only for like 10 minutes, 15 minutes, you know, just to, you know. Alright, here we go.
Why?
Okay, ready?
I wish it was on me.
Wilson, read about Snowball.
I've done my study.
Read it.
Oh.
What are you doing?
A spherical snowball with a radius of 70 centimeters is melting and its radius is decreasing at a constant rate of 2 centimeters per minute. How fast is the volume decreasing half an hour later?
Okay, what are we finding? Anyone? Okay, what would I call that? dVdt. Okay, what was I given? Okay, I'm given 2 things. Let's make sure which one's a rate. Okay, R is 70 is not a rate, but what does it say about the radius? It's decreasing at a rate of 2 centimeters per minute. So that means that dr dt is 2. That is wrong. Fix it. Negative 2. Why negative 2? Because it's melting, right? The radius is going to be shrinking. Okay, then for my when, this is where it gets a little bit weird. Okay, what is my when going to be? Half an hour later. Okay, so I'm going to put half an hour after the radius was 70. Now, here's the tricky part. They tell you at the beginning the radius was 70, but that's not when I want to know the rate. I want to know it in a half hour. So r equals 70 is a trick. You need it, but it's not the value we actually want. So let's do a little bit of easy reasoning here. Okay, in a half hour, how many minutes are going to go by? 30 minutes. It's going down 2 centimeters a minute for 30 minutes. How much is it going down? 60. So 30 minutes times 2, it's going to go down 60 centimeters. What was its starting radius? 70. So if it was 70 and it went down 2 a minute for 30 minutes, that would put it at 60. Or I'm sorry, at 10. Thank you. Woo. Got it? So radius equals 10 at that time. Now I'm going to walk you through it one more time in case anybody was confused. Okay, so half an hour is 30 minutes. 2 centimeters per minute for 30 minutes means it went down 60, but it started at 70. So 70 take away the 60 it shrunk, leaves me at 10. Okay, now from here, pull out your yellow sheet. What formula do we want for a sphere? Volume. Okay, 4/3 pi r cubed. That's the volume of a sphere, because it tells me it's spherical. Okay, let's take the derivative. So, derivative of v, what is it? dv dt equals, other side, my 3 multiplies down on my 4/3. What's going to happen with the 3 on top and the 3 on the bottom? Okay, just 4 pi r squared, then what? dr dt, very good. Then I was given dv dt, or wait, no, I'm looking for dv dt, I want dr dt. So what am I plugging in? Yep, dr dt, and what is it? Negative 2. And then what was my radius? 10. And that was centimeters per minute. Okay, so let's think about, I have 4 pi r squared times dr dt. So what is 10 squared? 100 times 4? 400 times negative 2? Negative 800 pi. What are my units? Centimeters cubed per minute. Why are they cubed? Okay, volume, and I had a centimeter squared with another centimeters. Okay, that's why it's centimeters cubed. Also, you should know in your brain, though, if you decide not to keep track of it, volume is cubic. So it will be centimeters cubed. Now, the only time that will change for my sciencey people is if it's milliliters, that's already volume. They're not going to put milliliters cubed. That's the only way that they could trick you if you're kind of going backwards. Milliliters already is a volume measurement, so they wouldn't put that with a cubed on it.
So, for
Okay.
example, if it's negative 800 pi, and that's
Can you say that one more time? If it's what?
So like negative 800 pi ml and a negative.
That would already, so if it was in milliliters, just pretend, even though it's ice, not water, it would be negative 800 pi milliliters per minute.
Alright, but it's like multiple choice and like
Yeah.
A to B,
And they would never make it multiple choice with different units. They wouldn't do that. The only time you'd see that is if it's free response and they tell you to put units, don't put milliliters cubed. Everything else, though, you do it. Good? No, fail. Okay, last question. We are gonna do this one. Oh, we have one more. Well, yeah, we have to do
We
this
should
one.
just cut it out.
Okay, fine. We can do enough pink. All right, you ready? Ready for level 2? Okay?
That was creepy.
Yes, ma'am. Anna, you have a question? Or you just had your hand up?
She's just like this.
Your text right here. Because I'm.
Hey, y'all are gonna do so great. Okay, so if you want to, in your notes, put pink examples so that you know we switched to the pink paper instead of the
I
yellow.
don't like this. Do you have the equation?
Yes. It is blank, but I can let you take a picture of mine. That way you have both. Okay, so the first one we're gonna do that I want you to start on your own is gonna be car A and car B, right here, this one. Okay, this one. So I want you to label it. What number are we on? I'm gonna keep going from the same numbers as yesterday. So are we on 7?
Yeah, no, literally something.
Okay, what's your notes? Do it how you want.
I numbered this first and I did one more.
Oh, I got you. That's fine.
Bro,
You go ahead.
He just said spitting games. You're different.
Hey, we accept you how you are. Okay? You're welcome to be in my class no matter what.
Unless you're from
I mean, I shouldn't even know that about any of you, so. Number 6. Okay, this is how I'm numbering it. I don't care if you do it differently for you. Your own choice.
Big James got MAGA written all over him.
Okay, here we go. Okay, we're going to draw a little picture first. So it says, car A is traveling south at 40 miles per hour towards Millville. Car B is traveling west at 30 miles per hour towards Millville. If both cars begin traveling 100 miles away at the same time, at what rate is the miles per hour, is the distance between them decreasing? Okay, so never eat soggy waffles.
just remember weed.
Huh? Weed. It's like weed.
When you spell weed.
News. Or never ever smoke weed. You guys ever have that one? No, I didn't come up with it. My own students came up with it. Okay, so ready? Car A is traveling south.
Alright, what about North and South?
Okay, there's car A. This car. Okay, it's a car, obviously. Okay, here goes car B. It's traveling west.
If ain't born is born, you know what they say, we shorter.
She put up in the road.
She could help out.
Okay, they are traveling towards Millville. Both of them are traveling towards Millville. So let's do find, give, and when. Okay, it says car A is traveling south 40 miles per hour. What is that for my given? How fast is car A going? 40, that is d/dt, yeah? So, the speed of car A is how fast that side is changing. Now, question, should it be a positive 40 or a negative 40? Negative, because what's happening to his distance away? It's decreasing. He's going towards it, right? So, this side is shrinking, so I'm going to make it a negative 40. Okay, car B is traveling west at 30. That means that dB/dt is negative 30. Yes, sir. What's your question? Good? Okay. All right, let's do our when. So it says both cars began traveling 100 miles outside Millville at the same time. At what rate is the distance between them decreasing after 90 minutes? So I'm going to put, how far away did they both start? They started 100 miles away. but then I want 90 minutes later. So we'll think that through in a second. Okay, but they started 100 miles away, but that's not when I care about. I want it 90 minutes later. Okay, so if they're asking me to find the distance between them, that would be here. What have you drawn? What geometric shape? Okay, a right triangle. Now, distance between cars. Do we want to call it D for distance and have to say d dt over and over again? Or would you like to call it C?
Let's call it Z. DZ.
C. Fine. Okay, for cars, distance, whatever you want. Okay, so I'm finding then dc dt. Okay, I want to know the rate of change of side C of the triangle, which is the distance between the two cars. Okay, so now let's talk about our when some more. So I'm going to have to do my equation a little bit later, even though we know it's Pythagorean theorem. Okay, 90 minutes later. So my car is starting. Let's do car A first. Car A. He's starting 100 miles away. In the first hour, how much closer will he get if he's going 40 miles per hour? Okay, so minus 40. So in 1 hour, he'll be 60 miles away. So far, so good? Okay, now he needs to go another half hour. How far is he going to make it in half an hour if he's going 40 miles per hour? Only half of that, which would be 20. Okay, so if he goes minus 20, how far away is he? 40 miles away. So my A side needs to be 40. Okay, one more time, then you're going to do B on your own. So if he's going for 90 minutes, that's an hour and a half. So in the first hour, he'll travel 40. That makes him only 60 away. Then in the second half hour, he's going to only travel 20 more, which puts him 20 more closer, which would put him at 40. So in an hour, he goes 40. He's at 60. Then in a half hour, he goes 20. Now he's 40 miles away. You do car B.
Yes, ma'am.
That's how far away he would be from Millville at that point. So he would have traveled 60, so he'd be 40 away. Okay, now you do not have to show your work like this. I totally don't care. It's however you want to do it in your own head. Okay, so let's talk about car B. How far away is he? 100. In the first hour, how much closer is he? 30, so he'd be 70 miles away still. Then in an extra half hour, how many is he going to make it? 15 more miles past 70, he's going to make it to where? 55.
Just B.
What'd you say?
Just B.
Yeah. Okay, so now I know my A and my B. Let's do our equation. So 3 sides of a triangle, we're doing Pythagorean theorem. So A squared plus B squared equals C squared. Now we're taking the derivative. Now when we did this with the ladder side was a constant. So when I took the derivative, what happened to it? It just became 0, right? Okay, but in this case, that's not going to happen here. What's the derivative of A squared? 2A dA dt. What's the derivative of B squared? 2B dB dt. And then what's the derivative of C squared? 2C dC dt. Now let's plug in. So 2A, what's A?
40.
Okay, negative 40, or wait, positive 40, sorry. Okay, 40. And then what's dA dt? Negative 40. Plus 2B, what's B? 55. And what's dB dt? Negative 30 miles per hour equals 2C dC dt. And then what do I notice about my C? I never went back and found C, so I'm going to have to do it now. How am I going to do it? Using the original Pythagorean theorem. So I'm just going to do it on my calculator. You can write it down if you want to. But my side A was 40. My side B was 55. So I'm just going to do in here 40 squared plus 55 squared. And then I'm going to square root that answer. So I get 68. Okay, and I'm just going to round it to a whole number just to keep count. It's 68.007, so we'll just call it 68. So plug in a 68 right here. Okay, and then I'll put a little arrow, had to go back and find. Okay, so from there, what is 2 times 40 times negative 40? Good, negative 3,200. 2 times 55 times negative 30 gives me negative 3,300. Put those guys together, what do you get? Negative, they're both negative though. So 6,500. And then 2 times 68 gives me 136 dCdt. And then my last step, I just have to divide by 136. Is it odd to you that dCdt came out to be negative? No, why not? What is happening to the cars and their distance? Decreasing because they're getting closer and closer. Okay? 79.41. There's the number right there. Okay? Now, I didn't keep track of units because the numbers got kind of big, but I can go back and label the units. If this is a distance, what would its rate of change be? Miles, miles squared, or miles cubed? Miles per hour. Okay, could you put MPH? Sure. That's the only one you could use an abbreviation for, but that would be fine. Okay? And then also remember, the negative means distance between cars is shrinking. Is decreasing would be the technical word there. Make sense? Hard or not too bad? Not too bad?
Miss Jenny,
Yeah.
where did you get the 68 from?
Where did I get the 68 from? I had to go back and find it using Pythagorean theorem. So I did this. I did 40 squared plus 55 squared equals c squared, and then I solved using the calculator. It doesn't come out to exactly 68, but it's like 68.007. Okay?
So if it's going south and west, that's negative, and then east to south.
Okay, so that's a good question. So he said if it's going south and west, it's negative. That's actually wrong, because what if my car was traveling away from Millville south? Then what would his distance from Millville be doing if he's going away? Getting bigger. Now, the one thing I will say on the AP test that they're good about is they'll give you a picture. They won't make you draw it yourself, but that paper would take many papers if I put a picture on each one for you. Okay? Last one today, this one right here. Number 3. It says a 3 next to it, it's really going to be number 7 for us, because it's right here. Huh?
Let's get over with.
Let's get it over with. It's what I like to hear. The last one. Okay, so this is number 7 in your notes. Number 7 in your paper. Okay, so find, given, when, equation. Okay, it says, at the instant when, keyword, the radius of the cone is 3 inches. Where are we putting that under? The when. So the radius is going to be 3 inches. Okay, then it says, the volume of the cone is increasing at 9 pi cubic inches per minute. What is that? The given dVdt. and it's 9 pi inches cubed per minute. Remember, cubic inches and inches cubed are the exact same thing. Okay, then it says, if the height is always 3 times the radius, I'm just going to underline that and put a question mark. That doesn't really fit anywhere. Find the rate of change of the radius at that instant. What am I finding? The rate of change of r, so dr dt. Okay, let's write our equation. Okay, remember what I told you yesterday. If it's a cone or a cylinder, they'll give you the equation for it usually. So v equals 1/3 pi r squared h. If I asked you to take the derivative of that, what rule would you need? That needs product rule. Okay, unless I can sub one letter out of the equation. Remember what we underlined. What did they tell us here? Height is always what? 3 times the radius. And if the height is always 3 times the radius, then what can I do? Substitute h out, then it's all r's, then no more product rule. Remember, you only have to do product rule when you have a mix of different letters. So I'm going to come back over here and I'm going to say, okay, well let me sub h equals 3r into the volume equation. So now I have v equals 1/3 pi r squared, and now my h is a 3r. Well then, how does that simplify to where I don't need product rule anymore? Okay, r cubed, and what happens with the third and the 3? Gone, gone. So then really, volume, my new and improved volume equation is just pi r cubed. And now, no more product rule, no more fraction, nice and easy. What's the derivative? dv dt on this side, 3 pi r squared, put a what at the end? dr dt, and then we're ready to plug in. What's our dv dt? 9 pi on this side, 3 pi r squared on this side. What's my r? 3 inches. Okay, then a dr dt over here. What is 3 squared for this part? 9 times 3 more? 9 times 3 is 27 pi, and then what's my last step to solve for dr dt? Divide the 27 pi to the bottom. So divide by 27 pi, divide by 27 pi. And dr dt equals, can that reduce? 1/3. What happens to the pi's? They can cancel out. So gone, gone. Okay, now if my cone is getting bigger, does it make sense my dr dt came out positive? Yeah, because if my cone's getting bigger, my radius is going to be getting bigger as well. Now let's talk about units. Radius is a distance. What will its units be? Inches, inches squared, or inches cubed? Inches per minute. Good? Okay.
How do we differentiate between using one and using another?
So if it's a distance, you're going to have units per time. If it's an area, you're going to have units squared per time. And then if it's a volume, you're going to have units cubed per time. And then remember, the only exception to that would be milliliters. Everything else you'd be good on.
What's that right now?
Milliliters are already a volume, so you wouldn't have a cubed on that one. But it would say in the problem, like,
So you would just leave it.
yeah, you just leave it.
What liters?
All right, what'd you say?
What liters?
The same. Yeah, anything with liters. Usually, though, they don't use that system.